In our last session, we went over how to solve systems with elimination. The thing is, those equations already had opposites set up nicely. But sometimes you do not have opposites already set up. So you're going to have to multiply one equation or sometimes both equations in order to make opposite values. And so we call this elimination with multiplication. There are some teachers who call it the linear combination method because that's really what you're doing. So depending on which teacher you have, some call it linear combination, some call it elimination with multiplication. I call it super fun. But anyway, what you want to do is make sure that you have opposite variables, because once you have opposite variables, then you're allowed to zero out one of the variables, and that allows you to solve for the other. So if I look here at equations A and B, I see that I've got x and 4x. I've got 3y and 3y. So it looks like to me, this might be the easier equation to zero out. So if this is a 3y, what zeroes out a 3y? A negative 3y. So let's multiply this equation by negative 1. However, it's an equation. So remember, what you do to one part of the equation, you must do to every part of the equation. That's the only way to maintain equality. So 3y gets multiplied by negative 1. So does this 8. So does this 4x. And what I normally do is, I won't write multiply by, but I'm doing this for us today. We're going to multiply the whole bottom equation by negative 1. And when we do so, 4x times negative 1 is negative 4x. 3y times negative 1 is negative 3y. 8 times negative 1 is negative 8. And look at that. I've got my opposites already set up for when I add. So when I add these two equations, 1x plus negative 4x is negative 3x. 8 plus negative 8 is 0. Now I'm going to divide both sides by negative 3, and I find that x equals 0. And now I need to find the value of y. And out of these two equations, which one looks easier? Please remember I'm lazy, so I'm going to go into the simpler equation, and this one has fewer crazy coefficients. So if x plus 3y equals 8, I have 0 plus 3y equals 8. 0 plus 3y is just 3y. And then we're going to divide both sides by 3. And I find that y equals 8/3. So I think my solution is going to be 0 8/3. I'm not sure. So I'm going to get my trusty TI calculator, and the TI calculator will help me find my answers. Yes, I'm going to have to cover up the work for a second. So I have 0 plus 3 times 8/3. I should get 8, and I do. Okay, so let's look at the next one. 4 times 0 plus 3 times 8/3. And I get 8 there, so guess what? That's my right answer. So on this one, I'm normally going to skip this step, but I'm so afraid that some of you're going to see 0 and automatically think, no solution. I wanted you to see that you divide both sides by negative 3, you get 0. I wanted you to see the step here where 8 divided by 3. Some of you will not know what to do, so I just want to show you. Divide both sides by 3. You're left with 8/3. And I want you to see that sometimes you get a fraction answer. What I don't want to see is you panic if suddenly an answer has a fraction and you have no idea what to do with them. So you can see that we've sort of worked with this already. Anything I give you will not be uglier than the notes. I'll make the notes ugly. And then when you do your practice or graded assignment, it won't seem as horrific. I've never used horrific in a math class before. New one. All right, let's look at equations A and B. And I just covered up my negative sign there that I don't want to do. So I have negative 7x versus x. I have negative 3y versus 5y. It looks like I want to eliminate negative 7x. And the way to eliminate negative 7x is to introduce a positive 7x. So let's multiply this x times 7. But remember, it's an equation. So if we multiply this term by 7, every other term gets multiplied by 7. So the top equation is going to stay the same. Negative 7x minus 3y equals negative 18. The bottom equation we multiply by 7. X times 7 is 7x. 5y times 7 is 35y. Negative 2 times 7 is negative 14. So here it is. And now we're going to add. When we add, my x terms will eliminate. I add negative 3y plus 35y, I will get 32y. When I add negative 18 to negative 14, I get negative 32. Now I need to divide both sides by 32. And when I do that, I find that y equals negative 1. So I know that y equals negative 1. I must find the value of x. So when I look at my two equations, oh my gosh, of course I'm going to use equation B. That's so much easier. So if I have x plus 5y equals negative 2, x plus 5 times negative 1 equals negative 2, x minus 5 equals negative 2, and adding 5 to both sides, I find that x equals 3. So I think my ordered pair solution is x equals 3 and y equals 1. But again, I don't know that that's my solution until I substitute. So that's what I'm going to do now. So does negative 7 times 3 minus 3 times negative 1. What does that equal? I hope it equals negative 18. And yes, it does. Okay, I'm almost confident. So x is 3 plus 5 times y, which is negative 1. I should get negative 2, and I do. So I was almost sure that this was my correct answer. But once I check it, I know for sure that it's the right answer. Okay, so there's number 2. Now I want to look at number 3. So number 3, I can eliminate 3x with a negative 3x if I choose to do so. Or I can eliminate this 4y with negative 4y. And it looks like that's what I did. So in order to make this negative 4y, we have to multiply this term by negative 4. But then we have to multiply this term by negative 4 and that term by negative 4. So my top equation stays the same. 3x plus 4y equals 10. My bottom equation, x times negative 4 is negative 4x. Y times negative 4 is negative 4y. 12 times negative 4 is negative 48. And I see my opposites, so I want to add these equations to eliminate the y. When I add 3 plus negative 4x, I get negative 1x. 10 plus negative 48 is negative 38. Now, if negative x equals negative 38, then positive x will equal positive 38. And for this equation, that's a no-brainer. I'm substituting into equation B. If x plus y equals 12 and x is 38, then subtracting 38 on both sides tells me that y equals negative 26. So I think x is 38 and y is negative 26. I think. But remember, I want to be sure. I don't just want to be sure, I want to be doubly sure into both equations. So I'm going to take 3 times 38, 3x, plus 4y, 4 times negative 26, and I should get 10. Ooh, and I do. And then I'm going to take x plus y, 38 plus negative 26, and I should get 12, and I do. So I'm not just sure, I'm doubly sure because I substituted and checked it into both equations. And now let's try a few where I don't spell out what's eliminated. So when I look at these two systems, here's what I see. I see x versus 3x. Well, I could make this negative 3x. I have 2y versus 2y. What if I make this negative 2y? That way I'm not having to multiply. All I'm having to do is employ a little sign change. So my top equation is going to stay the same. My bottom equation will be multiplied by negative 1. So 3x times negative 1 equals negative 3x. 2y, times negative 1 becomes minus 2y. And then 6 times negative 1 becomes negative 6. And look what happened, y'all. I've got opposite variables. So when we add here, I find that negative 2x equals 2. And if negative 2x equals 2, dividing both sides by negative 2 tells me that x equals negative 1. So right now I've got x equals negative 1. Now I want to solve for y. And to me, the easier equation is equation A. So if x plus 2y equals 8 and x is negative 1, I have the equation negative 1 plus 2y equals 8. We will add 1 to both sides. I'm going way ahead of myself here. I find that 2y equals 9. So y equals 9 divided by 2. And I think that's what it is. Where did I get this from, Robodeer? Well, 2y divided by 2 equals 9 divided by 2. And y is 9 halves. You want to put 4.5? Knock yourself out. We're going to get the same solution anyway. So let's check this one. So x plus 2y. X is negative 1 plus 2 times y. Y is 9 halves. Do I get 8? Yes, I get 8. Okay. Now let's look at equation B. 3 times x. 3 times negative 1 plus 2y. 2 times y. Here, I'll do a fraction for y'all that need it. There it is. I should get 6. And I do. So guess what? That's the right answer. I know for sure that's the right answer. And now I go to number 5. Equation A, equation B. Okay. I see a negative x. And I have a 2x. Can I turn this into negative 2x? Yeah, and then that will help me eliminate. I also see I have a negative y and a negative y. I just need to make one of those a plus y. So I think that's what I'm going to do. I'm going to take this top equation and I'm going to multiply everything by negative 1. So negative x times negative 1 is x. Negative y times negative 1 makes this plus y. Negative 8 times negative 1 is 8. I'm going to leave the bottom equation alone. And now when I add these two equations, 1x plus 2x is 3x. My y's will zero out. 8 plus 2 is 10. And I find that x is 10/3. And now to solve this one, I don't like either of these equations. There are too many negatives. But check this out. Look at this equation C, x plus y equals 8. Dude, there are no negatives. There's not a lot of there's no multiplication that has to happen. I think I want to use that equation. So I'm going to go into equation C, where x plus y equals 8. and x is 10/3. And in order to solve this, we're going to subtract the 10/3 from both sides. And watch me, y'all, I'm going back to 5th grade. I'm going to go back to 5th grade right here, or 4th grade. 8 is really 8/1 if I were to write it as a fraction. I'm going to leave this as negative 10/3. In order to subtract fractions, you need a common denominator. So if I multiply in the denominator times 3, I multiply in the numerator times 3. So I really have 24/3 minus 10/3, which is 14/3. Woo! So I think my answer is 10/3, comma, 14/3. I think that's what it's going to be. I need a moment. That was a lot of fractioning. Okay, so let's go ahead and substitute here. I want to know, does negative 10/3, oh, I do that every time, minus y, which is 14/3, what does that equal? Oh, good. It equals negative 8. So now let's take 2 times 10/3 minus y. And I hope I get 2. Yes, I get 2. And the reason I hope I get that answer is I don't know if I want to rework that, to be honest. But since both of these equations checked, I know that that order pair is the right answer. All right, number 6. There are no built-in opposites. So I need to find some other method to solve this. So can I turn 3x into negative 2x? Or can I turn 2x into negative 3x? Nope. Can I turn 3y into negative y? Nope. Can I turn negative y into the opposite of, yeah, this one, by multiplying by 3. So my top equation is going to stay as is. My bottom equation will get multiplied by 3. When I do that, I get 6x minus 3y equals 3. Adding here gives me 9x. Adding here zeroes out the y. Adding here gives me 9. So if 9x equals 9, then x equals 1. And y'all, this has smaller numbers, but there's a negative, and I'm just not feeling negatives today. I choose to substitute into equation A. So I have 3x plus 3y equals 6. And a lot of you will skip this step, and I'm okay with that. I do it for me because that's how I was programmed to do Algebra 1, but also it lets me see where I need to substitute. That's the main reason I do it. I mess up enough. I don't need any more opportunities for mess ups. So 3 times 1 is 3. I'm going to subtract that 3 from both sides, and I find that 3y equals 3, so y equals 1, and I think my order pair is 1, 1. 3 times 1, 3. 3 times 1, 3. Is 3 plus 3 6? Yup. 2 times 1 is 2. Is 2 minus 1 1? Yup. How you like that high-tech checking? All right, so I know that's the right answer. Okay, I'm feeling comfortable. I'm going to try one more. Let's see how it goes. So here's the conversation that I have with myself. And for real, this will be the conversation I have with you. Can I turn 4x into the opposite of 3x easily? No. Can I turn 3x into the opposite of 4x easily? No. Can I turn negative y into the opposite of negative 2y? Yeah, I can. What's the opposite of negative 2y? Positive 2y. So how can I turn negative 1y into positive 2y? Oh, that's easy, Robodeer. Multiply by negative 2. And when I multiply by negative 2, I find that negative 8x plus 2y equals 8. Let me double check. 4 times negative 2 is negative 8. Negative y times negative 2 is plus 2y. Negative 4 times negative 2 is positive. Yes, that's right. The bottom equation I'm going to leave alone. And I'll get 3x minus 2y equals 7. All right. Now I'm going to add negative 8x plus 3x is negative 5x. My y's will zero out. 8 plus 7 is 15. And when I divide both sides by negative 5, I find that x equals negative 3. And now I need to solve for y. And equation B has fewer negatives, so that's the one I'm going to go into. What'd you learn in math? Oh, my math teacher taught me how to be lazy. Yeah, I don't call it being lazy, I call it being efficient. So 3 times negative 3 minus 2 times y equals 7. We'll get negative 9 minus 2y equals 7. And then we'll add 9 to both sides. Negative 2y equals 16. So it looks like y equals negative 8. Oh, I'm done. My bad. So it looks like x is negative 3 and y is negative 8. I'm not sure that's right. I mean, I am, but I'm not sure it's right. So I want to check my answer to make sure I am right. So let's take 4 times negative 3 minus y, which is negative 8. And I hope I get negative 4, and I do. Now I'm going to take 3 times x, negative 3, minus 2 times y, which is negative 8, and I should get 7. And I do. So it checks for equation A, it checks for equation B. So I am sure that that is my answer. All right. So that's how you change one equation to make opposites. Sometimes you're going to have to change both equations. So let's look here. So if this is 2x and this is negative 3x, what number can I turn both of those into? Well, I can turn them into 6x. You're going to look at the least common multiple, which you may remember from common denominators and all that jazz. I mean, I could say, let's turn this into negative 20y and let's turn this into positive 20y, but I like smaller numbers because there's less room for error. And these are already opposites, so I don't have to worry about multiplying a negative and forgetting an opposite somewhere or bringing in an opposite that doesn't belong. So I think my magic number here is 6x versus negative 6x. So the top equation will get multiplied by 3. 2x times 3 is 6x. Negative 4y times 3 is negative 12y. 8 times 3 is 24. So far, so good. It's what I did on the previous problem, except I've got to do it twice. So this bottom equation, I need to make negative 3x. It'll get multiplied by 2. So negative 3x times 2 is negative 6x. Negative 5y times 2 is negative 10y. And then 10 times 2 is 20. And look at this, y'all. I've got my opposites. So these will zero out. I'm left with negative 22y. When I add these, 24 plus 20 is 44. Okay, so negative 22y equals 44. When we divide by negative 22, we find that y equals negative 2. So now I've got to find the value of x because I know it's something comma negative 2. I'm going to look into equation A, fewer negatives. 2x minus 4y equals 8. Okay, so I don't know what x is, minus 4, but I know that y is negative 2. So we have 2x plus 8 equals 8. When we subtract the 8 from both sides, we find that x equals 0. Therefore, divide by 2, x equals 0. And y'all, let me show you how easy this one is to check. If x equals 0, this is gone, right? And I'm left with negative 4 times negative 2. Does that equal 8? Check. Now look in equation B. That's zeroed out. So I have negative 5 times negative 2. Does negative 5 times negative 2 equal 10? Yep. Check. So guess what? That's right. Okay. So that's what you do to solve two equations, or to change both equations. So let's look at number 9. So here's how this works. Hindsight being 2020, I probably would have messed with 14y. Because a lot of you would see 4x and 6x and think 24x. And I would have to say, no, go smaller. Look at 12x and negative 12x. Okay? So it looks like that's what I did for these notes. So I want the top equation, to be positive 12x. So everything multiplied by 3. 4x times 3 is 12x. 2y times 3 is 6y. 10 times 3 is 30. Okay? Bottom equation, 6x times negative 2 is negative 12x. There's my opposites, guys. 7y times negative 2 is negative 14y. Negative 5 times negative 2 is positive 10. So it looks like these are my opposites. So now I'm going to add 6y plus negative 14y is negative 8y. 30 plus 10 is 40. When we divide by negative 8, we find that y equals negative 5. And now I'm going to look into equation A. All of these are equally yucky. So I think I want to look at equation A because I don't have to worry about negatives. And y'all, I'm actually going to scoot this over because I don't want to run into that down there or that up there. So equation A, 4x plus 2y equals 10. And now I know that y equals negative 5. So 4x minus 10 equals 10. I'm going to add 10 to both sides. And I find that 4x equals 20. So x equals 5. So I think my solution is 5, negative 5. Okay. So I want to substitute that in, and then we'll see how that works. All right, so let's do it. I have 4 times 5 plus 2 times y. I got 10. And then I have, just kidding, 6 times x, which is 5, plus 7 times y, which is negative 5. And I should get negative 5, and I do. So guess what? That's my right answer. So I know I'm good. And then I get to number 10. And you're thinking, this lady's crazy. She's written this twice. Well, here's why I did this. You see how it says you try? At this point in class, I would say, okay, try it. Because some of you would eliminate x, but there are some of you that would eliminate y. And so for those that eliminated x, suppose I gave you the solution for eliminating y. You'd have no room to put your answer. So I just wanted to give y'all space in case you wanted to do one or the other. So let's start by eliminating x. For those that want to eliminate x, I need to make this 40 and this negative 40. I could go 80, but remember, you always want to think smaller. So to make the top equation 40, let's multiply by 4. And I'll get 40x plus 36y equals 48. The bottom equation needs to be negative 40, so we'll multiply by negative 5. And I'll get negative 40x minus 30y equals negative 60. And when I add to eliminate, I find that 6y equals negative 12, and so y equals negative 2. And out of the two equations, substitute into one. I'll go ahead and substitute into A. So in the equation 10x plus 9y equals 12, I know that y is negative 2. So 10x minus 18 equals 12. We add 18 to both sides. If 10x equals 30, then x should equal 3. So it looks like my ordered pair is 3, negative 2. And I could check it, but I'm going to go ahead into this one and eliminate the y. So let's take a minute here. To eliminate the x's, I turn these into 40x and negative 40x. What should I do here? And don't tell me 54. How about if we use 18y and negative 18y? Okay, so that means the top equation will get multiplied by 2. So 10x times 2 is 20x. 9y times 2 is 18y. 12 times 2 is 24. The bottom equation I need to be negative 18y. So let's multiply by negative 3. So we'll get negative 24x minus 18y equals negative 36. And when we add, we'll eliminate the y's, but we'll be left with negative 4x equals negative 12. And so x equals 3. And for this one, I'll substitute into the bottom equation just so you can see what's what. The bottom equation is 8x plus 6y equals 12. X in this problem is 3. So I have 24 plus 6y equals 12. So let's subtract the 24 from both sides. In doing so, I find that 6y equals negative 12, and so y equals negative 2, and my order pair is 3, negative 2. Ah, look at that. It's in both of them. Okay. All right. So that takes care of number 10. So regardless of what variable I eliminated, I would get the same solution. So for these two, if I wanted to eliminate x, these need to be some form of 15x. Oh, don't change, Rover dear. Do what you did up there. Okay. So let's make this 15x and let's make this negative 15x. That way you can sort of see. So I see that I need to multiply here by 3. So I'll get 15x plus 9y equals 24. In order to make this negative 15x, I'm going to multiply by negative 5. So we'll get negative 15x. 7 times negative 5 is negative 35y. 10 times negative 5 is negative 50. So when we add, my x's will eliminate, and I find that negative 26y equals negative 26, and so y equals 1. So let's substitute into equation A. If 5x plus 3y equals 8, 5x plus 3 times 1 equals 8. If 5x plus 3 equals 8, then 5x equals 5, and so x equals 1. Okay, so it looks like 1, 1. So that's for those of you who choose to eliminate x by making them 15x and negative 15x. If you chose to eliminate y, you would want 21y and negative 21y. So the top equation would get multiplied by 7, and you'd have 35x plus 21y equals 56. The bottom equation, in order to make this negative 21y, you would multiply by negative 3. We'd get negative 9x minus 21y equals negative 30. Okay, that's fine. So when we add, we'll eliminate. We'll get 26x equals, 26. So x equals 1. Okay. And I'll go into equation B for this one. So in the equation, 3x plus 7y equals 10. X is 1. 3 times 1 is 3. We'll subtract the 3 from both sides. If 7y equals 7, then y equals 1. So look at that. My order pair is 1, 1. So what is the goal here? The goal here is to still make opposite variables, okay? So that when you add the opposite variables, they zero out, they eliminate. And in doing so, you're left with one variable, one equation, and you find the other. So in these cases, you have to change both equations. Sometimes you'll only have to change one equation here, but the goal still is to make opposites to eliminate.